Hey guys, welcome back. So we're going to talk about our third method for solving quadratic equations today. The first method being factoring. Okay, so we can factor it if it's factorable and get our two solutions using the zero product property. The second method was completing the square. So we're going to do that now on this equation here just to kind of refresh your memory, but also we're going to use this as kind of a structure for how to get the third method, which is the formula. All right. So the first thing we would have to do if we were completing the square on this is note that my first term is not a perfect square. So I want to make it a perfect square, so I'm going to multiply everything by 2, which is going to give me a 4x squared plus 40x minus 94 equals 0. Then I have to add the 94 to the other side because I want to leave a space for my perfect square trinomial. So I'm at 94 plus whatever that value is. Now, because my a value is not 1, I'm going to use the expression b squared over 4a. Now, I'm going to also use my new a and b. So I'm going to use the b is 40 and the a value is 4. So this is going to be 40 squared over 4 times 4. So it's actually pretty easy to do. It's 1600 divided by 16, which is going to be a 100. So that's going to complete my square on the left. So we have our perfect square trinomial on the left, which is going to factor down to, remember we're taking the square root of this first term, so 2x, and the square root of the third term using the plus here. So this is going to be a 10 squared, and we're going to add the 94 and 100 to get 194. Right? So then our last step, or almost last step, would be to take the square root of both sides because we're trying to get rid of this square, which leaves me with a 2x plus 10 equals plus or minus the square root of 194. Now, normally we would try to simplify the square root of 194, but it's not, doesn't have any perfect square factors. It ends up being 2 times 97, and that doesn't make it any smaller. So we're going to subtract 10, and we're going to divide everything by 2 to get the x by itself. Okay, so that's just a little rehash of completing the square. We're going to use those same steps on a standard form equation to get our formula. So the quadratic formula, some of you are going to find it very useful because you like formulas and you're comfortable with them. You've been using them a lot in science class. And some people are going to prefer completing the square because you like the methodology, the steps as you go. All right, so let's look at this equation that's in standard form. So notice that everything is set equal to 0, and I have an a, b, and a c value on the left. So how would we go about getting a formula from this format? Well, we're going to follow the same steps that we just did. We need a perfect square in the first term. So what we're going to do is multiply everything by a, just like we multiplied everything by 2. So this is going to give me an a squared x squared plus abx plus ac equals 0. And this is going to look kind of messy because it's a lot of letters everywhere and not any numbers. Okay, you don't need to memorize this. This is just one of several ways to derive the formula. I just think it's valuable for you to understand where this formula comes from so you can kind of appreciate the ease of using the formula. Okay, so our next step, what we did was we moved the 94 to the right. So we're going to take this AC as our constant and move it to the right. So a squared x squared plus abx plus something that's going to complete the square equals negative AC plus, again, whatever that value is. So we're going to use the fact that we're going to assume that a squared is not a 1. So we're still going to use b squared over 4a. But now our b is ab. So we're actually going to have ab squared divided by, and my a value is now a squared. So 4 times a squared. If we simplify that using our rules of exponents that we hopefully are familiar with, we get a squared b squared over 4a squared, which looks messy, but the a squareds actually cancel out. So what we're going to do is add b squared over 4 to both sides. Okay, now that gives us a perfect square trinomial on the left. I know it doesn't look like it, but if you look at your first term, you have a perfect square. And if you look at your third term, you have a perfect square. So this is going to simplify down to, or factor down to, ax plus b over 2 squared. Remember, we take the square root of the first term, that's this guy, and the square root of the third term, which is that guy, and we set it equal to, now remember, on the example, we added 94 and 100, our perfect square, so we're just going to add these two as we would normally add fractions, right? So we need a common denominator, which is going to be 4, which is going to be 4ac, or negative 4ac. So what we end up with on the right, if we combine those, is negative 4ac plus b squared divided by 4. So now they have a common denominator. And just like before, we're going to take the square root of both sides, okay, which is going to simplify the left down to ax plus b over 2, and the right side is going to simplify. Remember, this is the same thing as saying the square root of the top over the square root of the bottom. So we can't really simplify the top, so we're just going to leave that as a plus minus square root of, and I'm just going to rearrange this as b squared minus 4ac because that's what the formula format is. And then we're going to simplify the square root of 4 to 2. So that when we subtract, just like before, we subtract b over 2, now they have a common denominator, and the only thing left to do is to divide everything by a, which is just going to tack an a onto here as a divisor. Okay, so let's look at this formula in its glory. All right, so our x value is going to be equal to negative b plus or minus the square root of b squared over, or sorry, minus 4ac over 2a. Okay, so this is the formula that you kind of need to imprint in memory. It does make these quadratics a little easier to deal with, depending on if you're comfortable with formulas. So let's look at it in action. Let's use this 2x squared minus 9x minus 44 equals 0 as a basis for this, okay? Oh, I do want to add one thing. So if you skip through the whole process of how to get this formula, that's okay. You don't need to memorize it. I'm not going to test you on it. However, one thing you do need to put in your notes is this part under the square root. Okay, the part under the square root is called the discriminant. Okay, and this discriminant actually tells us some valuable information about the equation. It tells us how many solutions that we're going to have. So if you, after you simplify this b squared minus 4ac, if you end up with a square root of 0, okay, well obviously the square root of 0 is 0, so we're going to only have one solution when that happens. Okay, now the more common scenario is we end up with some positive number. Okay, so if you end up with a positive discriminant, this is our typical situation where we're going to have two solutions as normal. Okay, now the more rare situation, but you do need to be aware of it, is when you simplify that discriminant, if you get a negative number, well, that gives us a negative square root, which we don't have a way in math to express as a real number. Remember, I mentioned it before, it's an imaginary number. So when we have this negative discriminant, this is going to tell us we have no real solutions. Okay, so you can actually stop at that point, stop working and say, oh, this has no real solutions if that's negative. All right, so let's go back to our example. Notice it's in standard form, right? We have an A, a B, and a C, and everything is equal to a 0, which is what we want. So if you need to rearrange your equation to get it into standard form, that's what you need to do. And then it's just as simple as plugging in values, right? Plug and chug. It's a negative b, so I use parentheses for each one of my variables in order to fix this situation here. I don't want to accidentally mess up signs. So the negative goes with the 9. So it's a -9 here and a -9 here. And then my a value is 2, so I'm going to put a 2 here and a 2 here. And then my c value is -44, so -44. And now it's just a matter of simplifying in the correct order. Now I highly recommend that you do the discriminant first. Do the part that's under the radical, because that's going to tell you if you can stop or not. All right, so 9 squared is going to be 81. -4 times 2 is -8. And then -8 times -44 is 352. So we're actually add 352 to 81. So my discriminant ends up being 433. So it's definitely a positive number, which means it has 2 solutions. Okay, but I'm not done. I have to actually continue the work so I can get my 2 solutions. So now the rest is just simplifying what else I have. I have a -9, so a negative is a +9, plus or minus the square root of 433, because that's what I calculated here. And we're going to divide the whole thing by 2 times 2, which is 4. I don't believe 433 simplifies, so I'm just going to leave that as my solution. And that's how the formula is applied. Okay. Now I will mention one thing that you need to be aware of when it comes to these solutions. If you end up with a perfect square discriminant right here, you do need to simplify that all the way. So you need to actually come up with the 2 solutions using that perfect square. Okay. In this case, it doesn't, so we're just going to use this as my answer. If I ask you to do exact solutions, okay, I mean I want the square root. All right. If I ask you for approximate solutions, then I'll probably tell you to round it to like the 10th place or the 100th place or some other place value. What that means is you have to actually calculate using your calculator the square root of 433. Okay, and we have to add 9 and then divide the whole thing by 4. That gives us one answer. But then we also have to find the other answer. So negative radical 433 plus 9 divided by 4. So we actually want those decimal values. Okay, and I don't have an actual calculator in front of me, so I'm not going to do that. But if I asked you to do that, I need the actual decimal values, so whatever that would be. If I ask you for exact values, then I want the part with the square root. All right, guys, I'll see you in class.